In 2007, astronomers spotted a massive 54-ton asteroid roaming space relatively close to our planet. But later they lost track of it. That's why the space rock was declared a lost asteroid. Almost 2 decades have passed since then. And in November 2023, a report claimed that the lost asteroid, aka 2007 FT3, might hit Earth in 2024. Such news sounds ominous. But how true is it? Well, NASA disagrees. The U.S. Space Agency has refuted the worrying claims. This statement was issued in response to the announcement that there was a 1 in 11.5 million chance of the asteroid striking our planet on the 5th of October, 2024. The Space Agency states that at any time in the next century, there are no known asteroids that could pose an impact threat to Earth. NASA and other space agencies are watching the skies nonstop, determined to find, track, and categorize asteroids and NEOs near Earth objects. Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects. Inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they might turn into a real threat to the world should a direct collision occur. Luckily, the larger an asteroid is, the easier it is for our planetary defense experts to find it. The orbits of the largest space rocks around the sun are normally well known and determined for years and even decades. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object reaching 1,610 feet across. It might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Asteroid 99942 Apophis, also known under the dramatic name of the God of Chaos, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years.
If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, It was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown. 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risk, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 to 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Yup, moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shock wave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying in all directions.
Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet, the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured. But fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years, and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet. It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. Planets couldn't produce enough oxygen, so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And, of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system. But that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile-wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super-powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They, in turn, generate tsunami waves as high as the Empire State Building. 5 minutes after the impact, the meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface nonstop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ramp. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud the window panes around you burst into pieces. And then you see it. A giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 miles deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves, like we could hide in bunkers deep underground and survive. Such bunkers would already come in handy since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak some havoc. For example, the asteroid 1990 MU. In 2027, it'll come alarmingly close to our planet. Many people fear that Earth's gravitational pull will trap the rock, which is the size of 2 Brooklyn bridges. In this case, it'll start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion. It'd be so bright, people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy that would then turn into heat. Everything around the impact site would catch fire. And if the asteroid fell in the water, it would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun. The world would be plunged into darkness. If the dust stayed in the air long enough, the climate on the planet would change and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit the Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 miles per second. Halfway through the flight, it split into several pieces. This caused several stronger shock waves. When the meteorites hit the ground, it caused a major earthquake, and the aftershock from the explosions shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 MU will move past our planet. We'll be safe. Whew! But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan, and it has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT4 got closer to our planet than all others have ever done. In November 2020, it flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there. Then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bully. Good thing we're protected by Jupiter. It's the largest planet in our solar system, and it has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news, considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid. But in 2006, it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space rock into smaller pieces. A massive explosion could be used to do this. People wouldn't even need to land on the giant asteroid. Getting close to its surface would be enough. Boom! A powerful burst of energy would split the asteroid into several large pieces and tons of debris. The smallest rocks would burn in the heat released in the blast, and it would also change the asteroid's trajectory. The larger fragments would burn up while entering the atmosphere. All witnesses of this unusual meteor shower would have a chance to admire a beautiful fire show. Another means of protection could be a kinetic battering ram. Simply put, it would be a huge object that people would send towards the asteroid approaching Earth. Or it could be a heavy spaceship. This is the method scientists produce to prevent the asteroid Apophis from falling to Earth. This guy is 1,200 feet across and often passes by our planet, coming as close as 19,000 miles above Earth's surface. The asteroid is going to pass close to our planet again in 2029, and there is a possibility that in 3036 it might crash into the Earth. If it happened, the explosion would leave a crater more than 3 miles across. Within 6 miles of the impact zone, all buildings and subway tunnels would be crushed or severely damaged. The event would also trigger a powerful earthquake. In the area of 30 miles away from the crater, car windows and window panes in houses would be shattered. And 75 miles away from the impact site, the earthquake would move furniture and buildings. One way to stop such a catastrophe is to build a heavy spaceship. It would take off from Earth, speed up, and then ram into the asteroid with great force. This impact would alter the course of the huge space rock, and it would fly past our planet. We could also try to stop the asteroid by wrapping it in foil. This would make its surface reflective, and then solar pressure might gradually change the asteroid's trajectory. Another alternative is using the gravitational tug. In this case, we would send an unmanned spaceship, large and heavy, toward the asteroid. It would fly over the space rock and slowly draw the thing closer with its gravitational pull. A small change, of course, would be enough to make the asteroid fly past our planet. Another way to protect Earth would be to build a system of giant lenses in space. Perhaps you've tried focusing sunlight with eyeglass lenses. Then you know how hot this sunlight can get. Now imagine having many giant lenses that are all directed at one point. Scientists think that focusing such a powerful beam of light on the asteroid would make the rock melt and evaporate, slowly changing its route. And one more way to protect ourselves from the asteroid would be to install several rocket engines on its surface. It would turn the space object into a rocket, and we could set its course from Earth. Rogue stars pose a much bigger danger. Like asteroids, they fly through space and can collide with anything in their path. The problem is that they have a gigantic mass, sometimes comparable to our Sun's. Around 70,000 years ago, a duo of rogue stars whooshed past the Sun. It didn't affect Earth, but caused some disturbance on the outskirts of the solar system. This event is likely to happen again, someday. The rogue star Gliese 710, about half the mass of our Sun, is moving toward our solar system right now. There's a possibility that it'll begin to grab asteroids from the outer asteroid belt and toss them at us. And then, rare meteor showers you can observe these days will become a regular occurrence. But right now, this rogue star is extremely far from our world, and there's a bigger chance that it'll pass by without affecting our peaceful existence.